All right, guys, so we are doing exponents. This is a review from Algebra 2, really, and Algebra 1. So hopefully we can go through A1 really. Well, didn't you learn about exponents in Algebra 1? All right.
Algebra 1 was so great.
Oh, that was easy.
All right, then jot these down. Let's go.
You have a really nice.
All right, guys, so product property, that's your first exponent rule. We'll start numbering. Remember this?
What?
Whoa.
What? Oh, you had to. Yeah, would you guys
Everyone.
Are you gonna get a person that can wonder like order that you get Christmas? Oh yes, I will. Yes, you will. Yeah, is that what you guys do? Yes, you will be on. It actually doesn't make any sense. Oh wait, I'm not gonna be like.
All right, guys, so product property, if you remember this from, whatever algebra class, if the bases are the same when you multiply, what do you do with the exponents? Yes, add them. So the first one, 2 squared times 2 cubed, that's going to be 2 to the what? Fifth. Now, could you actually do 2 to the 5th without a calculator? Yeah, what is it? 2 times 2, 8, 16, 32. So for your homework on this section, if they are huge numbers, if it's like 8 to the 5th, you can just leave it as 8 to the 5th. If it's something simple like 2 to the 5th, go ahead and multiply it out. But you will be doing this without a calculator, okay? All right, so number 2 there, what's that going to be? X to the, yep. All right, and number 3, A to the 13th, B to the 8th. Good. Everybody remembers there's a 1 there, even if you can't see it. Yes? Easy? Okay. Are you guys seeing now why we can do 2 sections today?
Yeah.
All right, power of a power. So when you're raising an exponent to another exponent, what do you do with them? Multiply. So I think we're on 4, 5, and 6 here. So jot them down, give them a try.
Does that mean we have to divide?
If you have a root, you divide. What?
That does one word.
We got to work on your vocabulary. That's a root. Yep. What about it?
That's us.
So, like, if you,
Exactly.
we'll get to, I think, what you're asking eventually. Okay. So, just hold your thought there.
I said it right.
Just, I think you're not in the same place as we are. So just hold on.
So I'm gonna like, yeah, I knew it.
Like fractional exponents mean roots. Okay. All right. So number 4, what's this one going to be, guys? Yes. Number 5. And T to the, good. And then the 6th one is going to be A to the over B to the, okay, and that's it. Easy. All right. We're off to a good start. All right, so quotient property. Remember, when you're dividing, you subtract your exponents. Okay. All right, guys, so number 7, 2 to the 8th over 2 to the 6th. That's really 2 to the 2nd. And what is 2 to the 2nd? Okay. All right, then number 8, what do we get? Perfect. That is what we're going to deal with, I think, on the next slide, possibly, is what negative exponents mean. You should never leave your answer with a negative exponent, okay? So okay with quotients? Oh, 0 exponent, I lied. We'll get to the negative exponent. All right, this one's not too complicated. Anything to the 0 power is 1. So what's 8 to the 0 going to be? 1. What is z to the 0? Okay, good work, guys. Yeah, we like those.
Our test doesn't consist of mostly those.
Okay, here we go, negative exponents. So a negative exponent, what that means is that you're just going to move whatever piece has the negative exponent to the numerator or denominator. So if it starts in the top, you gotta move it to the bottom. If it starts in the bottom, you can move it to the top. We'll do a few examples of these. What number am I on? Like 11? 11? Okay. All right, guys, so 2 to the negative 1, what's that going to be? 1/2. Good. And 4/3 to the negative 2. Yeah, so 2 ways you can think about it. You can flip it first and make it 3/4 squared, because you've dealt with the negative. Or you can square them first and then flip it. I don't care what you do. Okay? We'll do more at the end, but basic idea here for negative exponents, okay? I think this is what you were talking about, okay, but I'm not sure. Kind of? Okay. All right, so go ahead and jot down that a to the m over n equals the nth root of a to the m, or the nth root of a all to the m. It's a lot of weird variables, I know. Okay, so the way these work, whatever your denominator is of your little fractional exponent, that is the root. So if this is a 2, that means square root. If this is a 3, that means cube. Okay? And then the numerator, that's what your base is raised. So the first one, that just means the square root of 4. You can think of it as, you can write the 2 and the 1 in if you need to, but you don't have to. That just means the same thing as that. And the square root of 4 is just 2. Okay. All right, so then 8 to the 2/3. that means the cubed root of 8 squared. And I think it's much easier to do the cubed root first and then square it, because you're always dealing with smaller numbers then. If you square first and then try to do the root, you have really large numbers, which tougher without a calculator. So what is the cubed root of 8? 2, and then 2 squared. Yes, you were just a step ahead. Does that make sense, guys? Okay. Questions so far?
For the product property, what if, like, two of your bases are different, like different numbers?
If your bases aren't the same, you can't add the exponents. So you just can't do anything with them. Okay? Anything else? So, let's do a couple. Let's start over with our numbering. We'll practice. We won't say examples, we'll say practice. Sorry guys, I'm not sure. So guys, go ahead and try doing these once you jot them down. Once you've tried them, talk to someone around you. I realize some of you have no one around you today, so find someone near you.
It's 1/16, it has to go.
Yes.
It is?
Yeah.
Okay,
All right, guys, let's look at them. For number one, I think it's much easier to simplify inside the parentheses first and then deal with the exponent outside. So if you're looking at c to the 5th over c cubed, how many c's are left and where are they? 2 at the top, right? And then d cubed over d squared, how many d's are left? Just 1, right? Okay, and then the 1/2, that means the square root of all of that. So what's the square root of c squared? C. And then you can't take the square root of d, so that's what it is.
Can you also
I would also take cd to the 1/2. Yes, very good. Okay, perfect. And pay attention to directions on quizzes, tests, stuff for this unit. If I say write it with, I might tell you no fractional exponents, that means you have to do the root. Or I'll say write it with rational exponents, that means I want them as fractions. Okay, so just pay attention to your directions.
All right. C squared, the 1/2.
It's not in parentheses, so, because this is really like,
Oh, it's just for the.
yeah, you see it? All right, guys, the second one then, what does the negative exponent mean we're going to do? Yep, they're both going to move. We're going to flip it, and then we're going to cube it. So it's really going to be q to the 9th. That's a 9, I promise. Over p to the 6th. And you're done? Yes? Okay. The last one, this means 1 over the cubed root of 64 squared. Well, what's the cubed root of 64? 4 squared. So it is 1 over 16 is your answer for that one. How do we do? Good, okay. Let's try again. All right, try these two. Jot them down. Try them out on your own. Talk to someone around you. See how you're doing. If you get stuck, let me know. You okay? I got it.
Maybe the other one was on the call.
That seemed like a lot.
Yeah, it's like really ridiculous. There's like weird
No, you're fine. You shouldn't have to sort it out. He has extended time, and so I'm sure I graded his like separately, and it just got put in the wrong file. All right, guys, how you doing? Okay. right, guys, we gotta keep moving here, so let's look at them. So number 4, 27a to the 6th to the 1/3. That means the cubed root of 27a to the 6th. Well, what's the cubed root of 27? 3. Cubed root of a to the 6th? B squared. Good. Yeah, you just divide. 6 divided by 3 goes in evenly. That's your answer. How many got that one? Okay. Not bad. All right, number 5, I would simplify each set of parentheses first and then start combining things. So a to the 4th, b to the 6th squared, that's really a to the 8th, e to the 12th, times, this is a to the 10th, b to the 5th, over a to the 7th, b to the 19th. So I can go ahead, and then in the numerator I really have a to the 18th times b to the 17th over a to the 7th, b to the 19th. Okay, then just ask yourself, looking at my a's, how many are going to be left and where are they going to be? So how many are going to be left? 11. Where are they? Yeah. So this is a to the 11th. Then look at your b's. How many b's are going to be left and where are they? 2 down below. Yep. Okay. Rather than subtracting and seeing the negative and thinking about moving it, just ask yoururself, like, okay, I had 17 up here, 19 down here. How many are left? Okay. I don't want you to have negative exponents in your answers. Okay. So you'd have to do one more step from there. Okay. All right. Questions so far? Are we good, Rachel? Okay. You need to like stand up and run around. Okay, we will do these. We'll do the first one together. All right, so we're going to write the expressions using rational exponents. And we'll go through these together, guys. So the first one there, it's asking you the square root of r to the 7th, s to the 5th, t to the 24th. And I want you to write it with rational exponents. So rational means fraction, okay? There's a 2 here, even though you really can't see it. There's a 2 there, even though you can't see it, okay? So when you are turning it from the root back into the fraction exponent, you are just taking each exponent and dividing it by that root. So this is really r to the 7/2. This is what you're talking about?
It's like bringing out the remainder. Remember that? It's like it's like R instead of like simplifying it out.
Simplifying, yes. Writing it as rational exponents, no. Okay. So this is going to be s to the 5/2, and then t to the 12th. Okay with that? All right, that's your answer. It's pretty easy when you're writing rational exponents. The only thing you need to be careful of on the second one, that's just a number in front. Remember, we aren't doing 16 divided by 4. You are doing the 4th root of 16. So what is the 4th root of 16? 2. Okay, so it's going to be 2, and then s to the 3rd, t to the 15/4. Okay? With me? Okay, so again, reading directions is very important. There will be a section that says write with rational exponents. There might be another one that just says simplify the radical. Okay, so two very different answer types. Anybody, anything? All right, so we're going to express these using a radical. So we're sort of going in reverse here. Jot them down, and then I'll show you how. It's very easy once you understand what you're doing. All right, guys, so the first one, anytime you are turning it back into a radical, all you have to do is look at your two exponents. We've got 3/4 and we've got 1/2. What would the common denominator be between those? 4, right? So we're going to make this the 4th root. Okay. And then the x, it already had 4 as its base for its fraction, right? So it's just going to be x cubed. But your y, what do you think it's going to be? Yep. Okay. And now two things you can do with your 5. You can leave it outside. Or if you want it under the radical also, it has to be raised to the 4th power. So I think the first way is easier. But I would take the other way too. I mean, the other way is not wrong at all. It's just easier to do the first one. So you guys try the second one. Let's see what you get. It's okay either. Alright guys, did you leave the 12 outside? Okay, and then what root are we looking at? 12, yeah. And so it's going to be a to the 8th, good, and b to the 9th. How do we do on that? Gus? Anybody struggles? Please ask if you're not seeing something. Good? Okay. All right. Let's simplify. I think this is what you were talking about, Blue?
Yeah.
Okay, we finally made it there. Last slide in the notes, and we got there. So jot them down. We'll go through the first one together. I'll have you do the second one on your own. No, it's a certain individual who just really enjoys running in the hallways during class, so don't think anybody was chasing him though. All right, guys, so the first one, I'm asking you the square root of 32, x to the 7th, y to the 4th, z to the 3rd. So the variables, I think, are actually the easier part on this. The harder part is figuring out the coefficient. So square root of 32, is that a perfect square? No. So what is the biggest perfect square it's divisible by? 16, right? Isn't 32 16 times 2? So what's the square root of 16? So that means I'm going to have a 4 outside, leave some space, and I know I'll have that 2 left over under the square root. All right, then here's the division, Felipe. How many times does 2 go into 7? 3, right? So that's x cubed out here, and then how many are left over? 1. The leftovers stay under there. So then y to the 4th, how many times does 2 go into 4? 2. Anybody left over? No. Then we look at z, it's z cubed. How many times does 2 go into 3?
So most of us have been doing like this really good stuff.
Goes in there just once, right, with 1 left over? So that is your final answer. I didn't write it very well with my spacing, so let me rewrite it. Okay? All right, so you guys try the next one. Now realize it's the cube root of 54. So you're thinking biggest cube that 54 is divisible by. You can make the little tree if you really like your tree too. However you can simplify that, you go for it. Are you struggling on the 54? Yeah. Do you guys know your perfect cubes? Yes, 27 and 2. Very good. So if you forget, make a list. Think, okay, 2 cubed, that's 8. 3 cubed, that's 27. 4 cubed, that's 64. 5 cubed, 125. Really don't usually need anything, like I usually don't ask you anything bigger than 5 cubed, okay? So of those, which one is 54 divisible by? 27. 27 times 2, right? So what is the cubed root of 27? All right, so we know we have a 3 out here. I'll leave lots of space. And then cubed root 2 is left under there. Okay? Then the variables, which, do you guys agree the variables are easier? Yeah, okay. How many times does 3 go into 9? 3. Nobody left over, so we're just there. How many times does 3 go into 7? Twice. Leftovers? 1. How many times does 3 go into 11? 3. Leftovers? 2. That's it. Okay. All right. Questions on exponents? So this is what we're dividing by. So I'm basically doing 9 divided by 3. Okay, goes in evenly. So I have 8 cubed out here, no A's left.
Right.
Then 7 divided by 3. Well, that goes in twice with 1 left. Okay. All right, questions? Are you guys still alive?
This is still A1.
That's still 8-1. We're almost ready for 8-2. Check. What? The A and the C? What? I want to answer your question, but I don't know what it is. Oh, okay. You're good? Okay. All right. So, I think I put your homework. All right, guys. Something good to remind yourself of. You're going to need this when you get to your homework. Remember, if you have a negative in parentheses squared, that's positive. But if you have the negative without parentheses, like this really means the opposite of 2 times 2. Whereas this one really means negative 2 times negative 2. Okay, so just be careful with your signs. That's an easy thing to mess up. All right. Stop this recording. And we got to do 8-2 now. This is